Hello everybody, my name is Lawson Shaw, and my team here, we are Group 13. This is our thermodynamics final project. First, we want to start with the conceptual processes behind a steam engine. A steam engine converts heat energy from hot steam, typically from a boiler, into work through expansion under pressure. The remaining heat can be allowed to escape or condense in a separate apparatus, a condenser, for maximum efficiency. To achieve high efficiency, the steam must pass through a wide temperature range due to expansion within the engine. The most efficient performance is achieved by using a low condenser temperature and high boiler pressure. Steam can also be heated further by passing through a superheater, which consists of parallel pipes exposed to hot gases in the boiler furnace, allowing steam to be heated beyond the temperature at which it is typically produced by boiling water. The reciprocating engine is a type of steam engine where steam under pressure is admitted into a cylinder, pushing the piston and producing rotary motion. In a double-acting engine, steam is admitted alternately to each side of the piston. Simple steam engines have one cylinder for steam expansion, while compound engines have two or more cylinders for increasing size, which leads to greater efficiency. The first, smallest piston is operated by high-pressure steam, and the second by low-pressure steam exhausted from the first. Steam turbines use high-velocity steam to rotate through a rotor through a series of stationary and moving blades, which results in the generation of electric power. Compared to reciprocating steam engines, steam turbines are more compact and can handle higher temperatures and expansion ratios. Steam turbines are widely used to generate large quantities of electric power through steam. Now I'm going to give a literature review on the history of the steam engine. The first steam engines were invented by the hero of Alexandria in the 1st century CE, but practical use of steam power did not occur until the 17th century. In 1968, Thomas Savery patented a pump to raise water from mines using condensing steam. In about 1712, Thomas Newcomen developed a more efficient steam engine with a piston separating the steam from the water. James Watt greatly improved upon Newcomen's engine in 1765 by adding a separate condenser and developed a new engine that rotated a shaft and had other improvements as well. In the 18th and 19th centuries, inventors in France and England developed early forms of steam power transportation. In 1769, Thomas Joseph Cugnot built a cumbersome steam carriage for roads, while in 1803, Richard Tretherick built a steam locomotive that successfully ran on a horse-car route in Wales. The first practical steamboat, the Charlotte Dundas, was built by William Symington in Scotland in 1802. The commercial success of steam engines on railways was realized with the rocket, developed by George Stephenson in England in 1829. Clearly, the steam engine has been a vital force in the beginning of the Industrial Revolution through allowing efficient travel. However, steam engines eventually faded out as they were large, heavy, and expensive and were replaced with internal combustion engines. Although internal combustion engines replace the steam engine as the primary means of vehicle propulsion, there has been renewed interest in the steam engine industry, especially in the later half of the 20th century, due to growing air pollution concerns caused by the burning of fossil fuels in internal combustion engines.
Now let's talk about the construction of our steam engine. Here, as you can see, we 3D printed a lot of it. This was done using a 3D printer that was owned by one of our buddies, Cost Efficient. As you can see, we have some nuts here inside of the wheel. We've got over here on the other side, you can see this is a, what are these things called again? Golf thing. It's the tee, a golf tee. Yeah, a golf tee. And this is part of a hanger, as well as this right here. Some of it also required some Lowe's shopping, but that's not a big deal. If it's for the betterment of our steam engine, we're willing to do anything.
Our first complication was the 3D printing. The printer that we originally used was not adjusted correctly. The parts did not fit together. The measurements were slightly off. And so we had to spend time filing down the parts and hope that they would work. which did not end up working no matter how much WD-40 we ended up applying. So our solution was to reprint with a better printer, and we double checked to make sure that all the parts and measurements were lined up correctly to make our current model.
Our second problem was the bearings. We found bearings from a skateboard. Those ended up not working. They would not fit in the project. So we then went to Lowe's, and then we went to an auto center, and then we ended up at Tractor Supply, all of which did not have any bearings that would fit our project. After looking on Amazon, we never found any bearings that would work. So in the end, we decided to solve our problem with the 3D printer.
Yeah, so in order to kind of construct a non-working model for our steam engine, we ended up having to 3D print the bearings that we could not find, just as a placeholder, just to kind of make it look like a steam engine. Doesn't really work though, so.
Due to the 3D printing bearings, it does not spin when we apply just the air compressor, but it does work when we use the hand. If you will do as so, when we spin, there is such high friction that I can spin it and it will work, but the air compressor cannot overcome the force of friction and it does not work.
In the end, we faced a lot of problems throughout the process due to a lot of restraints in time and also just materials in general. I think we found a way to make this work. We were able to end up making a model in the end, which really showed us how a steam engine works, and we learned a lot. In the future, we'd probably be able to build a steam engine if we were given more time and a lot more resources. All in all, I'm very happy with how the model came out and with all that we learned. Thank you.